Hi everyone, welcome to our video on generative AI. Artificial intelligence has been around for decades, but the field is constantly evolving and new trends are emerging all the time. The latest flavor of the technology, generative AI. The best-known example, ChatGPT, can write software, hold conversations, and compose poetry. In this video, we will dive deeper into what generative AI is, how it works, and dive into some concepts like generative networks, diffusion models, and transformers. Generative AI is a subfield of artificial intelligence that focuses on creating models and algorithms that can generate content without explicit instructions. Unlike traditional programming, where the programmer needs to define every rule and parameter, generative AI models are trained on large datasets of examples and can create new content that is similar to the training data. Generative AI has many applications in various fields, such as art, music, design, and even medicine. For example, generative AI can be used to create realistic images and videos for movies and video games, to generate personalized music based on a user's preferences, or to design new molecules for drug discovery. In technical terms, generative AI refers to unsupervised and semi-supervised machine learning algorithms that enable computers to use existing data to create new possible content. As for now, there are three most widely used generative AI models, and we're going to look briefly on all. Generative adversarial networks. GAN uses two neural networks to compete with each other to become more accurate predictions. Transformer-based models, technologies such as generative pre-trained GPT language models that can use information gathered on the internet to create new textual content. Variational autoencoders work by building on neural network autoencoders made up of two different neural networks, encoders and decoders. There is another type of model that are very popular nowadays called diffusion models. They are a type of generative model that generate new data by simulating the diffusion of particles in a high-dimensional space. I forgot to mention there are also autoregressive models are models that are generally used in finance industry for time series forecasting. N, generative adversarial network model, consists of two main components, a generator and a discriminator. The generator takes random noise as input and generates a new sample that resembles the original data distribution. The discriminator takes both the generated sample and real data samples as input and attempts to distinguish between the two. During training, the generator tries to generate samples that are indistinguishable from the real data, while the discriminator tries to correctly classify samples as real or generated. The generator and discriminator are trained in an adversarial manner, where each tries to outperform the other. The transformer consists of an encoder and a decoder. The encoder takes the input sequence and generates a sequence of hidden representations that capture the information in the input. The decoder takes the output of the encoder and generates the final output sequence. BERT uses transformers just the encoder architecture, and GPT uses the decoder architect. The key innovation is the use of self-attention. Self-attention allows the model to attend to different parts of the input sequence while generating the output, so it helps it keep the context. During training, the model learns to assign different weights to different parts of the input sequence based on their relevance to the output. Variational autoencoder are used for unsupervised learning of latent representations of data. It is a neural network that is trained to encode input data into a lower dimensional latent space and then decode the latent variables back into the original input space. During training, the VAE is trained to minimize the difference between the reconstructed output and the original input while simultaneously maximizing the similarity between the distribution of the learned latent variables and a predefined prior distribution which acts as regularization term. Stable diffusion models leverages the perceptual power of GAN, detail preservation ability of diffusion models, and semantic ability of transformers and mirrors them together. It is a variant of the diffusion model that uses a latent variable to model the distribution of noise in the diffusion process. Instead of operating in the high-dimensional image space, it first compresses the image into the latent space. The latent space is 48 times lesser. Stable Diffusion first generates a random tensor in the latent space. The noise predictor UNet takes the latent noisy image and text prompt as input and predicts the noise, also in latent space, a 4x64x64 tensor. Subtract the latent noise from the latent image. This becomes your new latent image. Finally, the decoder of VAE converts the latent image back to pixel space. This is the image you get after running Stable Diffusion. A transformer language model is used as the language understanding component that takes the text prompt and produces token embeddings. The released Stable Diffusion model uses ClipText, a GPT-based model. This was just an overview on generative AI, but we hope you find it useful. Please let us know what you think about the generative AI models and what application you feel will be good fit for these in the comments section. If you haven't subscribed, please do and click on bell icon to get notified of any new videos.